In this video, I want to share the top 5 skills that I think are the most valuable to a developer's career path. I'm also going to outline the lessons that I've learned over the past 20 years as a software professional that allows me to earn over $300,000 per year. At the end of this training, I will invite you to become an early adopter of my complete course, and if you stay to the end of the training, you will receive an offer to save 30% off the full price if you enroll today. So first things first, why am I making this course? Well, I set out to create Succeed in Software with the sole purpose of consolidating all my career lessons into essentially a guidebook that junior and mid-level developers on my projects could follow and increase their value on the team. As much as I love working with other devs, the initial onboarding process for new devs can be very time-consuming. Technical and architectural ramp-up is inevitable, but best practices and veteran tricks felt like they should be taught separately. I kept wishing there was an online resource that I could point my devs to that would allow them to ramp up on their own time, but all the other courses and programs really only focus on code, frameworks, libraries, apps, and so on. None of them really focus on the other skills I find even more valuable: collaboration, communication, pair programming demeanor, unit testing, design patterns, core values like integrity, and so on. You could be the most talented programmer in the world, but if nobody wants to work with you, then you're really on your own. Ultimately, I felt it was time to simply create that online resource for developers just like you to potentially jump 10 to 15 years ahead of your peers by applying the techniques and mindsets that I use every day, which have allowed me the privilege of growing my annual income by 1,000%, from $30,000 in 2004 to over $300,000 in 2020, doing pretty much the same thing, coding software like websites and apps, offering technical advice to clients, and so on. And like Tony Robbins always says, I don't say that to impress you, I say that to impress upon you the possibilities of what you can achieve if you simply follow my training and apply the knowledge to your own career. The key takeaway, of course, is that it will be up to you to put in the work. This is not a get-rich-quick course. I'm not teaching you how to scam anybody or step on your coworkers to get ahead. It's the polar opposite of that. I'll be teaching you how to become the most disciplined, focused, ethical, and motivated developer you can be, while also being completely aware of how corporate politics and team synergy can make or break your opportunities for growth. Secondly, who am I? Well, I'm just a dev who's been lucky enough to have been coding a long time. I wrote my first line of code in 1988 when I was 7 years old on a Commodore 64, and even though all I really did was change the colors of the text in the screen background and play some short melodies that I made up, it really planted a seed. By 1996, I had started dabbling in HTML and eventually made my first GeoCities website for my Ultima Online guild, never looked back. And since then, I've been teaching myself programming languages, building a ton of websites for side projects, and really trying to push the boundaries of how I can use code, like building IoT gadgets with Arduinos and Raspberry Pis. And what I eventually learned over the past 20 plus years is that the skills that offer value to paying projects and enterprise systems are much different than the skills I was focusing all of my time improving. I was over here trying to make myself a super coder, learning everything I could, trying to be the expert and impress everyone to get promoted. But at the end of the day, nobody on my projects ever really cared. And it wasn't until I shifted my perspective and started to really empathize with the other people on my projects to understand what they perceived as valuable that my career really took off. And that's what I'm hoping to share with you in this course. So with that, let's jump right in. Starting with valuable developer skill number 5 in our countdown, the strategy pattern. Design patterns in general are pretty cool, and even if you've never heard the term before, odds are you're using one or more in your project already without realizing it. And some of the most well-known patterns are like the singleton, the factory, and the observer. When you stop and think about what design patterns really are and why they came to be, you can then start to understand why you would want to use them for your project or not. In a nutshell, design patterns are simply cool tricks to solve common problems that got really popular and were given a name. And that's really it. The one pattern that gets me the most bang for my buck by far that I hardly ever see any devs using is called the strategy pattern. And essentially what the strategy pattern is a way to write your code so that your services are referenced through an abstraction layer, which accepts a strategy and a payload. Now the payload works regardless of the strategy, and it's up to the strategy itself to perform any transformations or interpretations of the data to keep that contract intact. Now I realize that is a mouthful, so let's unpack that with a real-world example. Imagine you get a task to add analytics to your website. The ticket requires that 50 plus custom events be invoked at specific places in user registration, sales funnels, error screens, and so on. And this is really common when the product team wants to track how customers use the website. Imagine the ticket specifies using an amplitude account and provides some links to the basics of documentation and some code snippets. You implement the code and deliver the ticket exactly as it's described, adding the custom event hooks to all the various places of your website using the snippets that the docs recommend, and then you even demo that it's working to your product owner. Great job. Now, fast forward 2 months and the product owner comes to you and says, hey, you know what? Amplitude isn't really giving us the reporting we were hoping for, so we're going to switch to Mixpanel. I need you to use that instead, and we need it this sprint. Well, that sucks. And let me tell you, my friend, it happens all the time. The product owners are constantly being swayed by vendors to switch to their products, or some manager gets replaced and the new manager comes in and says, I see you're using X, but at my old company we used Y, so we should use that instead, for no reason at all. So given this scenario, what is the alternative to making over 50 changes to your code? The strategy pattern. Instead of coding that Amplitude event hook 50 times, imagine instead you had created an analytics service which exported a custom event function that accepted a strategy name and a payload. The strategy name would have been defined in some environment variable somewhere, something completely abstracted from the analytics code. And for the payload, the more vague the better. Along with your analytics service, you would have created one strategy called Amplitude, which would likely reside inside that analytics services folder, inside like a nested strategies folder. The first implementation would behave the same way as if you had coded Amplitude-specific snippets all over your app, but then when your product owner decides to change to Mixpanel, all you have to do is add a new strategy for Mixpanel, with likely one function to represent its version of custom event, and do any payload transformation logic in that one file that would likely just rename a couple Amplitude properties to Mixpanel properties, and then update the environment variable so the website is leveraging Mixpanel strategy, and then you're done. The website itself doesn't know that Amplitude changed to Mixpanel because that detail is abstracted away from the code. The best part of this approach is that your analytics service and the strategies you create have absolutely no application logic inside them, so they're typically exempt from any intellectual property claims from the client. That means that you can usually reuse them on any future project you'd like, or even open source them without any issues. This of course depends on any contractual terms you've negotiated with your client or employer, so please use your best judgment here. I've personally never had any issues with this, as I'm very careful to never reuse any application logic on any other projects, including my own, only utility logic. Now, there's a clear distinction between application logic and utility logic that we'll cover later on in the course, and ways to structure your project to support this mindset. But if you're new to these terms, a quick way to think about it is, the utility logic can be coded 100 different ways and the app will still work exactly the same. When the application logic changes, so does the user experience or the business offering. The ability to abstract and reuse utility logic has saved me countless hours on projects where I'm able to just plug in the MySQL strategy on the DB util, or the Elasticsearch strategy on the search service with the Redis strategy on the cache util, and so on. For practically no additional work up front, you become the dev that allows your product owner to change their mind on a whim without putting the roadmap weeks behind schedule. You become the dev that the product team wants to use over and over for features because you make them look really good to the executive team. They're able to try new ideas without much risk, and if they do make a mistake with a vendor, it's not a big deal at all. Your ability to correct their mistake quietly alongside other sprint objectives will hold a lot of weight the next time you need to push back on a feature request that goes against your gut instincts. Counting down to number 4, pure programming. Pure programming is a way to create functions whose output is defined by their input and have no side effects. Pure functions are one component in a collection of functional programming methodologies, but in my opinion, it is the most important. It can also be used in object-oriented programming and procedural programming languages, so it's that much more valuable. Let's digest what a pure function is, starting with a function whose output is defined by its input. Like, what does that really mean? Let's take a very simple function as an example. We'll make a function called add2, and it will accept two numbers, a and b. The function adds a plus b and returns the sum. If we give this function 5 and 3, it returns 8 every single time. And that's the key. When you give in 5 and 3, it returns 8 every single time. Very simple. The output 8 is defined by the input 5 and 3. It's very straightforward and obvious, but how can we change this function so its output is not defined by its input, so you can understand why this is so important? What if we had a condition like, if user is awesome, sum plus equals 5. Now for users who are not awesome, the function returns 8, but for users who are awesome, the function returns 13. This is really confusing, especially because the function is named add2, not add2 and maybe an awesome user bonus. This example may seem really silly, but where would this scenario pop up in the real world? Well, I see it all the time in like React components. A function is supposed to do something, but if some value in the state meets some condition, the function returns something else, like null. This adds a lot of complexity when we introduce testing, because now our tests need to consider external context factors like state, or like user in our first example. If we want our code to be portable and reusable, like I mentioned when talking about the strategy pattern, then it needs to also be agnostic and unaware of its surroundings. The output needs to be defined by the input, not by the input and some other stateful criteria. Any data that the function needs to deal with inside its context needs to be given to it as parameters. The second part of this pure function definition is that it has no side effects. So what is a side effect? Well, it's exactly what it sounds like. If something else in the app changes when we run our function, it adds a lot of confusion and complexity that will severely slow down troubleshooting and debugging efforts. This almost always happens because of mutation, which is essentially when we change the guts of an object or an array in memory, so the next time it's referenced, it's different than before. Imagine our function accepts two objects instead of two numbers, and imagine its purpose is to simply merge them together. The function should ultimately return a brand new object that is the direct result of merging the two that were given to it. In other words, imagine object A lives in memory bank 1 and object B lives in memory bank 2. Our pure function will only read from banks 1 and 2, and will return a brand new merged object that will be written to memory in bank 3 if it happens to be saved to a variable. If our function writes to banks 1 or 2, then we've created a side effect, and our function is not pure. Other parts of the app that are expecting objects A and B to contain certain data will unexpectedly receive objects that contain different data thanks to our function, or rather, no thanks to our function, and this is bad news. The rule of thumb, if your function receives an object or an array, it should clone them. If your goal is state management, then you need a state machine that's very tightly coupled to the state itself, so it's simple to manage. Some languages like PHP will take care of this for you and default to passing by value instead of passing by reference. And you have to explicitly notate that you're mutating your function's input if you choose to do so. Languages that pass by reference like JavaScript, you need to be careful and manually copy your data. It's worth mentioning that this will slow down your app slightly and increase memory and processing requirements, but the cost savings and reduced troubleshooting can typically pay for the hardware so many times over that it's not even worth debating. Number 3 in our list, local first development. There is immense value in writing code that behaves the same in any environment, tier, or any step of your CI pipeline. Code that has a bug in production but works in the staging server is extremely painful to troubleshoot and frustrates not only the entire product team, but also the customers who never really should have experienced the bug in the first place. I still witness devs who don't even run their code locally and just push it up, hoping that the CI build will pass and their pull requests will be eligible to merge. When there is a bug, they use like a deploy and test approach, which wastes hours and hours. Having no local dev environment is only slightly worse than having a bad one that replaces API calls with local static JSON files, or one that does checks like if the environment is production do X, otherwise do Y. What that does is set you up for a scenario where the code works locally but doesn't work remotely, for example in AWS. How many times have you heard a developer say, "I don't know what's wrong, it works on my laptop"? As a senior dev, this is just not an option. And the good news is there's an approach to solving all of this. Whatever code you are working on needs to be completely oblivious that it is running on your laptop, or dev, or stage, or test, or prod, or whatever you call the tiers in your infrastructure. It should not know if it's running in true application mode, or being pulled into a unit test, or being hit as part of an integration test, or as part of a load testing suite. What we want to do is define our interaction points between the code, which you deploy, and the systems, which you do not. For example, on one of my current projects, we have a MySQL database, a cache service, monitoring analytics, and 2 legacy services from Oracle and Okta. The local first development mindset tells me I need a Docker setup with a MySQL container, a Redis container, and then I need to develop a mock local strategy for the rest of the services using the strategy pattern we already discussed. These can still serve static JSON, but they will serve it from the Node.js API that the front end would normally call anyway. Instead of the Node app talking to Oracle and Okta, it returns some static JSON to satisfy the API consumer, and that API consumer is none the wiser that it's receiving static JSON. This separation of concerns allows me the ability to fully run my app locally. It makes API calls exactly the same as it does when running on prod. The front end calls the API on my Node apps, which makes SQL queries and leverage the cache layer all the same, but will receive pre-seeded dummy data either from the database or from the static files instead of real customer data. Being that my code is also being deployed to AWS, I know that my cache util is going to have at least 2 strategies, Redis for local development, and Elasticache for dev onward. Like I mentioned earlier, any special logic to accommodate these tools lives in the strategy, not in the app. Being able to fully run my production-ready code locally and offline is a huge value. When bug tickets are created, I can rule out 90% of possible causes in a couple minutes by trying to reproduce it locally. Most of the time, if I can reproduce it, it means the bug is in the code, and if I can't, it means the bug is in the data, and I will try again with like production data dump. If I still can't reproduce it, then most likely the bug is in a DevOps context, like a missing or incorrect environment variable, misconfigured security groups, or a firewall setting, and so on. I highly recommend mastering your local development environment. Leverage Docker, environment variables, and unit tests so you can be the dev who's known for finding and fixing bugs the fastest. The tools themselves are completely irrelevant. What matters is the process and the objective. Pick whichever tools help you achieve this objective, and you will achieve success on your team. Unit tests also bring us to number 2 in our countdown, test-driven development. Unit tests are the heart and soul of our application. They are its documentation and our evidence of competency. Unit tests not only prove that our application works how we expect it to, but also and more importantly allows for rapid prototyping and scaling, since they virtually eliminate the fear of regressions. Unit tests save the reputation of online businesses time and time again, and while almost every project I've worked on has pushed back against unit tests in some fashion, the projects that have embraced full test coverage and a TDD approach have had measurably more and productive dev teams, working much more on features and much less on bugs. My argument is always the same. The money will be spent regardless, either paying a dev to write the test or paying a dev to fix the bug. Regularly troubleshooting and fixing bugs instead of investing in test coverage is absolutely and completely backwards, and in any other professional industry, it just wouldn't be tolerated. Can you imagine Toyota being proud of their recalls when they skipped preventive due diligence? No way. Unit tests are a bit like health insurance. Investing in coverage is unappealing because few people think complications will happen to them in the near future. The investment cost is much more real to them at the moment than the potential disaster relief. As senior software engineers, it is our job to inform our clients of how real disasters are and how common they can be, especially in hastily written code. Clients need to understand how easily disasters can spawn from a simple oversight in the code and how difficult it can be to detect and fix, especially after the damage is done, and especially without unit test coverage. Tests are part of the deliverable, not some optional add-on. So how much coverage is enough? 80%, 90%? Well, in my projects, it's 100% and it's mandatory. Our entire application should be covered by tests, every statement and every function. And if that sounds intimidating or unrealistic to you, then you are going to gain a lot from my training as I explain patterns and concepts like currying and dependency injection that allow me to maintain 100% coverage in all my projects pretty easily. I don't personally enjoy writing tests. They're pretty boring, right? But TDD allows us to do rapid prototyping without worry, instead of spending hours debugging and troubleshooting an issue only to learn after a few hundred log statements and some breakpoints that some obscure function was making assumptions that were being caught and suppressed in a promise chain somewhere. Consider this harmless looking one-liner function. As harmless as this function may appear on the surface, it assumes global JSON and JSON parse, assumes user exists outside the block scope and not passed in, assumes user is an object, assumes user has a property called config, assumes user.config is an object, assumes user.config has a property called prefs, and assumes user.config.prefs is a JSON string. Code like this is extremely common. If any of the above assumptions are wrong, this function would throw an error. Having coverage and assertions for this function would almost certainly change the way it looks and behaves. Writing tests really isn't such a terrible experience when you consider having to deal with the alternative. Tests are very liberating. They make writing application logic so much more enjoyable. I hear the argument occasionally that some code is impossible to test, that there's no way to get coverage into some logic forks. Well, I appreciate the argument, but I've learned that if I ever find myself in a situation where I can't get coverage into a logic fork, I consider it a blessing. It's a red flag that my code is convoluted, which, thankfully out of habit and repetition, occurs less and less as I learn from my own mistakes and continue to discover new patterns that I'm going to share with you. Test-driven development is very misunderstood. I've heard developers describe it as write all your tests and then go back and start writing code to make all your tests pass. I won't say that's not the definition somewhere, but that's not how I learned it, and that sounds like a nightmare. TDD simply encourages us to write tests as we go, usually before the code, but sometimes after. The philosophy is that our logic and the corresponding test that proves it should be written within the same immediate time frame, before moving on to the next bit of logic. Writing tests before the code forces us to author concise, linear chunks of logic. our functions will be more portable and easier to read, and the specs will evolve as our codebase evolves. As I'll mention later in my course, small, modular, immutable, curried, and pure functions are the easiest to test. Knowing that massive objects and files which depend on external references create testing nightmares, we can simply avoid that style of programming completely to make our lives easier. Lastly, we've reached my number one most valuable skill in a dev's career: communication. Now, I don't mean general communication skills like using proper grammar and being polite. I'm specifically talking about communicating between the product's subjective and the technical objective. In order to be really great at communicating across all the various teams and key stakeholders, you first have to be able to put yourself in their position and truly understand what they really want. What is their underlying motivation and how do they define success, ranging from the ticket to the project to their career in general? For example, I've learned that graphic designers typically hate when developers offer suggestions or fail to implement their designs how they were presented in a comp. We as developers may not think that a 10 pixel margin versus a 12 pixel margin is a big deal, but to them it's a very big deal because it's literally what they're being held accountable for on the project. It would be similar to a designer creating some files in our codebase and naming them with underscores when all the other files use camel case. Their argument might be, I can still read the file name, and then we would start debating the importance of consistency, and ultimately the opinions would be ruled out by defined standards, the same way our opinion of a margin is irrelevant when it's defined in the comp. To put this in a real-world context, I regularly attend design walkthroughs. These are meetings where the design team showcases their latest comps for a new feature or section of the app, and it's my job to point out any potential challenges I foresee from implementing their designs. This could be some data in the comp that would require a new API endpoint to be created, or maybe a UX flow that appears synchronous in the comp, but is really asynchronous and would require the comp to change a little bit to represent the current infrastructure. Bringing up these issues really isn't a big deal. We just need to track the work with new tickets so our sprints don't get overloaded. Quite often during these walkthroughs, I will have very strong opinions of how I think the UI should be changed to offer a better user experience. Buttons that should be moved, or complicated form flows that should be consolidated or something. The problem is that the designer doesn't care about my opinions. I'm not on the design team. The only time I ever speak up and push back on a design is when I see some designs that will create an unreasonable amount of work for the dev team. When that happens, I'll say something like, hey, regarding the carousel, would you be open to us using the carousel component in our existing library? We can probably get the colors and layouts to match pretty closely, but the thumbnail styling might differ a bit. It'll save us a few days of work for sure. Putting the ball in the designer's court and making them understand they're doing me a favor versus me trying to undermine their designs has been extremely successful, and it makes them feel like the hero for saying, sure, I'll allow it and save you time. The underlying communication concept carries over to virtually any team on the project. If you want to get on the project manager's good side, for example, you can ask this person if they can show you any cool tricks in Jira to speed up your daily ticket triage. They typically don't want your help on their tasks, but they do want to feel important and useful, so if you can give them that opportunity, they will often be very thankful and think highly of you as a member of the team. It may feel backwards that the way to get people to like you is to get them to do favors for you, but it works really well. Most of the people I work with on projects will go out of their way to teach me something that they're especially good at, and it's a fantastic way to gain knowledge and skills outside of my comfort zone, as well as gain rapport with these people. The goal here is to become the jack of all trades, master of some, and always be interested in learning about the other components and the other departments, so that when you do have doubt in something, your questions will come across as genuinely wanting to understand, versus sounding like you're questioning someone's intelligence or competence. Of course, communicating with other devs is probably the most important layer in all of this because you likely share accountability in the code. Dev communication will grow the fastest and the deepest in pair programming sessions, and in contrast, will be the most challenging during code reviews and peer reviews. In my experience, giving constructive feedback in a code review is most widely accepted in the form of questions, where I appear somewhat ignorant and give the other developer the benefit of the doubt. Your goal here is not to come off as condescending or annoyed, even if you are. For example, using the phrase, "Can you help me understand?" is an almost surefire way to lower someone's guard and make them want to explain their code to you without getting defensive. If you see a bug, instead of saying, "You're missing a comma here, this will break," you can simply ask, "Do we need a comma here?" It's a rhetorical question, but it will put you on their side of the fence, essentially working with them to complete the code, versus being on the other side of the fence, essentially blocking their code until they get it right. These little subtleties and nuances are super annoying, and it can often feel like you're walking on eggshells with people, trying not to upset sensitive folks. But this is by far my weakest skill, and every time I improve even slightly, I find that I see immediate gains all around me on the project. One of the biggest tricks in communication that I've learned over the years is that if I'm even remotely unsure whether or not my written message could be interpreted differently than how I'm intending it, then I need to stop immediately and jump on a call with the other person. I found it typically takes a fraction of the time I thought it would to communicate a concern or give feedback to the other person, and I'm often much more able to communicate verbally that I mean no disrespect and I'm not bitter or upset about anything, whereas I may sound frustrated or irritated in writing. Being able to use body language and convey emotion and intent in my voice really helps solidify deep rapport with my fellow devs, as I really want them to understand that we're on the same team and I'm here to help them grow and succeed just like I'm here to help you grow and succeed. And with that, I'd like to go over the course outline and cover the skills that I use every day, which I will teach you that allow me to earn over $300,000 per year. The course is divided up into 8 sections, each with several modules that will cover a wide array of topics. As I record the modules and populate the course content, I may combine some modules that I'm about to list and will likely add additional modules to continuously add more value to the course. So please consider this as I list this outline. The welcome section will cover how to join the Facebook community, how to get technical and sales support, and how to get personal one-on-one consulting and advice from me to cater to your specific situation. The traits section will cover an array of topics including core values, the importance of diversifying your project portfolio, and some cancerous traits to avoid that get devs fired and blacklisted from projects. The practical section includes modules that cover a wide range of daily challenges and tasks that I encounter regularly in my career, and how to leverage my approaches to come out way ahead on your own projects. The collaboration section will cover various cross-team interaction techniques and how I've learned to excel in each area, ranging from one-on-one pair programming to building rapport with the executive teams. The networking section will talk about various outlets to use to market yourself to the outside world, which platforms to avoid, which to take advantage of, and which platforms to take seriously. The growth strategies section will cover methodologies and successful career decisions that I recommend to all my peers, which have helped me get to where I am now and continue to help me advance my own career. The fulfilling your dreams section will cover the steps you need to take to work for yourself and realize your own goals instead of realizing your employer's. I'll cover how I manage my debts and expenses, the process of becoming a 1099 independent contractor, and ultimately forming a corporation and investing in yourself. The last section is called Perspectives, which is where I'm going to interview colleagues in my network in various positions along our ideal career path, ranging from junior developer all the way to CTO. You'll gain valuable perspective on the challenges, responsibilities, and opinions from each role to help you ensure that the path you're currently on is right for you. So right now, you're faced with a choice. You can continue to work as hard as you can on your own for the next several years, hoping that your employer notices your efforts and decides that they want to pay you more money, or you could take charge of your software career today by letting me help you jump years ahead of your colleagues. Imagine you're in a maze and there's a $300,000 annual paycheck in the middle, and I'm essentially handing you the map that I used to find it. Enroll below right now to get full access to my course at the early adopter discounted rate. I will be raising the price of this course when I'm finished filming the content, so take advantage of this discount. Congratulations on your investment. I look forward to being your instructor, and I will see you soon.